know the properties of alkynes. Also, how to write their structural, molecular, and condensed formula. Also, how to identify them. The UPAC is the International Union of Pure and Advanced Chemistry. It's an international scientific organization non-affiliated with any government. The UPAC strives to advance chemistry by naming new symbols, units, and names. A hydrocarbon is an organic compound made mostly of carbons and hydrogens. It is possible to form double or triple bond to form between carbon atoms and even structures. Alkynes have an electronical configuration of sp and are unsaturated hydrocarbons that contain two or more carbon-carbon triple bonds. The molecular formula for this group is CnH2n-2, and alkynes have less hydrogen atoms than alkanes in alkenes.
Miss, I don't understand that problem.
And Lucía, would you like to explain to your friend how to solve it?
Of course. Well, the first step is to name the longest carbon chain. Then you have to number the carbon chain starting from the near triple bond. And the last step is to give the location and name of each, substituting as a prefix to the alkyne name.
The first thing you have to do is to name the longest carbon chain. Correct. Now, number the carbon chain starting from the near triple bond. Correct. Now, give the location and name of each substituent as a prefix to the alkali name. Okay, you got this number 3 because this number has to be the one that stands in the triple bonding, and it's the 3 and the 2 and 4. But you have to choose. Okay, the reason that he got this result is because the number 3 represents in which carbon the triple bonding stands. It can be in the 3 and in the 4, but you have to always choose the list. The name and sign gives it the 6th carbon from the longest carbon chain, and the termination is from the kind of carbon change that is an X sign.
To solve this, first we need to name the longest carbon chain. We know we have 4 carbons, so it's 2 times. Then we have to number from the nearest triple bond. 1, 2, 3, 4. We know that the nearest is 2. But we know that we have these
Carbons.
These carbons, and they are the 1 on the 2 and on the 3. We know these ones are called methyl. So we need to put first these ones. 2, 3, methyl, 2. Because we have 2 methyls, we need to put it dimethyl. First, we need to name the longest carbon chain, this one, and then we need to number it from the nearest end closer to
the triple bond. 1, 2, 3, 4. In this case, as we have 4 carbons, it's a tie. So then we need to give the location of the substituent, that in this case is a haloalkyne, and that it's chloro. It's 3-chloro. And the name is 3-chloro.
Now we're going to determine the name for this formula. Okay, we must first name the longest parent chain of carbon atoms, which is this one. It is a straight line. Then we must number it, starting from the lower to the greatest. The triple bond is present on carbon 2, so we must start it from right to left to right. Okay, since we don't have any branches, the name will be 2 because in the carbon 2 is present the triple bond dash. We have 4 carbon atoms and it is an alkyne because of the triple bond, so it will be butane.
Okay, for the structural condensed formula, we will need the structural expanded formula. The first one, it will look like the carbon and its 3 hydrogens. So in the structural condensed formula, it will look like carbon, hydrogen, 3. These 3 are these ones. In the second one, it has 1 carbon and 2 hydrogens. So it will be expressed in the condensed formula like carbon, hydrogen, 2. These 2 are this one and this one. For the third carbon, it's equal to the second carbon, so it will be written like carbon, hydrogen, 2. The third carbon is the same as the first one, so it has 3 hydrogens, and it will be written like carbon, hydrogen, 3. And we finish our condensed structural formula.
¿Lo digo todo?
Ya, dilo. Lo cortamos.
Hydrocarbon derivatives contain 1 or more heteroatoms, atoms other than carbon or hydrogen. Halogenated hydrocarbons have halogen heteroatoms. Oxygen is the heteroatom in alcohols, phenols, and ethyls. Triols contain sulfur as heteroatom, and nitrogen is the heteroatom in amina.
Hydrocarbon derivatives. The first type of compound that we have is the alcohol, which general formula is ROH, which is part of the hydroxyl group. An example of this is the ethyl alcohol. The next one is aldehyde, which formula is RCH double bond O. And an example of the aldehyde is the formaldehyde. The next one is organic acid, which formula is RCOOH. And an example of it is the acetic acid. The next one is the ether, which formula ROR. And the example of this compound is the methyl ether. Type of compound ketone, RCOR is its general formula, and an example is the acetone. Ester, which formula is RC double bond OR. An example is ethyl acetate. And then finally we have the amine, which formula is RNH2. An example is methyl amine. Of the nomenclature of alkynes video we have done, I know now that alkynes are organic molecules made of the functional group carbon-carbon triple bonds, and its formula is CnH2n-2. They are unsaturated hydrocarbons like alkenes, have the suffix ene. This time alkynes use the ending y and e. The suffix is used when free is only one alkyne molecule, which is a triple bond.
Hydrocarbons are one of the most important natural resources of Earth. Hydrocarbons bring us humans many benefits. We use hydrocarbons in the fields of food, clothing, housing, art, etc. The greatest amounts of hydrocarbons are used as fuel for combustion, particularly in heating and motor fuel application. Hydrocarbon contamination in the environment is a very serious problem, whether it comes from petroleum, pesticides, or other toxic organic matter. Environmental pollution caused by petroleum is of great concern because petroleum hydrocarbons are toxic to all forms of life.
Billions of people use a computer daily. Wall Street and all stock markets run entirely on computers. In fact, almost all important systems are automated. Without hydrocarbons, the world economy will crash hard.